Greetings, dearies.
Hello, how are you?
So what I'm going to do is I'll give you the definition, the things involved in statistics, how it works in reality, where we apply it,
Yes.
then we enter into calculations. Is that okay with you?
Yes.
All right. So it says here, statistics is a branch of science that deals with data collection, and
Okay.
we have data presentation and data analysis. So we have data collection, presentation, analysis. Then we also have here interpretation.
Yes.
Okay. Interpretation. In order to extract knowledge or information later used for making intuitive decisions. Okay.
Yes.
So it says data collection. When we speak of data collection, we have different methods here that are used to collect data. Okay.
Yes.
Have you ever heard of questionnaires?
Yes.
Okay. I can give you a piece of paper that is questions where you fill in your gender, your age, what you want to do when you grow up, your salary, things like that. That's a questionnaire, right?
Yes.
When you start filling in that information, I am collecting data. You are giving me data. Okay.
Okay.
And on presentation, that data can appear in a table like this, where it has name, gender, salary, things like that. Okay.
Yes.
Now, so that will be data presentation. On analysis, that's where we are looking now at, from this data, how many people were males, since we have gender, right?
Yes.
How many people were females in this collection? How many people have their salaries between 20,000 and 30,000? How many have salaries greater than 50,000? That's analysis now, right?
Yes.
On interpretation, that's where you might find someone saying, you know what? From this data, it seems we have many males who respond to our questions, and many of them, they have their salaries above 50,000. All right?
Yes.
After learning something like that, remember, we want to get knowledge or information, right?
Yes.
We have picked that we have many males. Then after picking that, we've picked that they have their salaries above 50,000. It means if we are selling a product, this is where now we want to make a decision, right?
Yes.
If we are selling a certain product, we would prefer to market mostly to males because their money is bigger, and we have many of men involved in our circle. Okay.
Okay.
So that's now the decision of the company. Okay.
Yes.
Another one is, a bank gives loans, right?
Yes. Yes.
If you go to a bank, they collect data, gender, salary, where you stay, that's your location, the type of loan you want, going on like that. So you find over years, people have been collecting loans. It means over years they've tons and tons of data piled in their systems, right?
Yes.
They can get to a point of saying, okay, from our results, we always see that if it is a male whose salary is less than 30,000 and they take a loan for a house, normally they fail to pay. Are we good?
Yes.
So they end up having a system that selects who is to get a loan and who is not to get a loan. How they do it? When you feed in your information, the system is trained to pick a pattern. If you fall within a pattern that you are a male, less than 30, earning less than 30,000, and you want a house, the system will decline your loan because it already knows the risk of you failing to pay it back. Okay?
Yes.
Do you understand now?
Yes.
All of this, that's statistics, and it even goes to prediction. Have you heard people say tomorrow it will rain? There is 70% chance that it will rain.
Yes.
All of that is because there is data, past data about wind speed, wind direction, heat levels. So with that data, someone will know that when these patterns appear, it indeed rains, and that's how they give us the statistics. It's not a gift of prophecy working, okay?
Yes.
All right. Then we are speaking of data. When we speak of data, we have types of data. Okay?
Yes.
So we have numerical data. Numerical data. Okay?
Okay.
It means these are numbers, okay?
Yes.
For example, your age, it's a number, right?
Yes.
Salary, it's a number, right?
Yes.
Okay, going on. Which other one we can put here, which is a number? Your maths marks,
Yes.
they are numbers going on like that, right?
Yes.
Then we have what we call categorical data. All right.
Okay.
It means this is data that is in categories. For example, gender. Okay.
Okay.
Blood group. You see, you belong in a certain category. Are we there?
Yes. Yes.
Here we can even have a height. Your height is a number.
Okay.
Okay.
Yes.
We can have height as a number, but if we put it into levels, if we put it, let's say your levels in maths, I carry 0 to 30% level 1, right?
Yes.
So when we put that into levels, there's level 1, level 2, level 3, level 4, level 5, level 6, level 7, and level 8 for you guys, right? So
Yes.
you are in level 8, right? So now it is grouped. You belong in a certain category, okay?
Yes.
So having data like that, whenever we deal with maths, the quickest way to understand what is happening is if you use a diagram, right?
Yes.
When you use a diagram, you quickly get a picture of what is happening. Because when data is in a table, I'll show you an example of a lot of data just now, okay?
Okay.
If data is in a table, presented in a table, you will not quickly know how many males are there, how many females are there. Are we good?
Yes.
But when you make a graph, the picture is quick. So under numerical data, we have what we call box plots. These ones, you know them as box and whisker plots from lower grades, right?
Yes. Yes.
We have what we call histograms. Are we there?
Yes.
We have cumulative frequency curves. You know them as ogives. Okay?
Yes.
We have scatter plots. We have density plots. All these graphs, they quickly give you a picture of what is happening in a numerical data. Okay?
Data. Yes.
Then, if it is categorical data and or nominal data, we have bar charts. A bar graph can quickly give you a picture. Okay?
Yes.
A pie chart as well. Now, what is the difference between a bar chart and a histogram?
Instagram that has spaces in between the bars. And
So a bar chart
spaces.
has spaces, right?
Yes.
Between bars. Good. Between bars. For example, we are discussing gender. So it can be male, we have a bar. Then female, we have its bar. It's not continuous, right?
Yes.
But if it is a histogram, we'll be having intervals 0 to 5, 10. So the graph will do like this. It will join. There are no spaces. Okay?
Yes.
So far as it is, we are just giving a picture of what statistics is about and how we quickly get answers from it. Okay?
Yes.
Can I now show you a lot of data and explain what will be happening? Is it fine?
Yes.
Okay. So let's do this and see. So look at this. Somebody collected the data. This is data in a table, right?
Yes.
There's gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, reading score. So the idea is someone is interested in student performance, okay?
Yes.
Then they want to see, does gender influence the way people pass in maths? Or which of the gender performs better in the subject of maths or reading, right?
Yes.
So gender, race, parental, lunch, test, you see it's in categories, right?
Yes.
It's categorical data. Then maths, reading, this is numerical data, right?
Mm-hmm.
So the data is so much. It's 1,000 rows. Are we there? So it means 1,000
Yes.
people collected the data. So from this table alone, you won't even know how many were females, right? And how many were males. So, and
Yes.
also, you won't even know if there is any relationship between what a person gets in maths and what they get in their writing. Are we good? That's where now you will have a summary. A summary quickly gives you a picture. And then from a summary, you can quickly get a box and whisker plot like this. Okay?
Yes.
So you see, from maths, you know that the minimum mark was 0, and there is a person who got 100, which became the maximum mark. We shall enter into these interpretations. Are we good?
Yes.
So you see, from that table of 1,000, this is the quick picture we can get. That, oh, so there's someone who created 0 and someone who got 100. It's now easy from the picture. Okay?
Yes.
Then we can, what type of a graph is this? Is this a bar chart or a histogram?
A histogram.
A histogram. From this, we see that many of the people are close to, we have many people between 60 and 70 here. Okay?
Yes.
And they got, we have a lot of people, their marks were between 60 and 70 somewhere here. Do you see that?
Yes.
You can't see that from the table, but from the graph. Then here, what type of a graph is this?
It's a histogram. Oh, there's
this
a
one.
scatter plot.
Scatter plot. A scatter plot, we are looking at a relationship. Does the math score have any relation to the writing score? So as it looks now, as the math score increase, the writing score increase, meaning there's a positive relationship. We shall discuss this deeply. Are we there?
Yes.
So it means a person who writes very well scores well in maths according to this data. Are we good?
Yes.
So you can't get this picture from the table. So that's about the summary, okay?
Okay.
Let's go back now to the lesson. So here, another simple example you come across that I want to give, which would show you how people end up having decisions. Have you heard of alcohol?
Yes.
With alcohol, you find that we have months January, then we have June and July, right?
Yes.
Then December, then we start again January, June, July, then December, right?
Yes.
Then again we start January. Someone is collecting data, January, June, July, then December. Now, from this, we say sales, okay?
Okay.
So someone is interested to see throughout the year, which of the months, what is the behavior of my sales, right?
Yes.
So you find January, June, right? Then November, December.
Yes.
Then we come January, June, then December. Again, we come back to January, right? June, July, then December, right?
Yes.
You see that there's a past pattern here.
Yes.
That every December, somewhere around December, there's an increase. You see that?
Yes.
So someone can now say, okay, in these months here, in January to July, it's like my sales are low, especially June, July. Then they say, what could be the reason? They say, it's winter, okay?
Yeah.
Then they notice December, November, December, the sales are high. Then they say, in reality, what could be causing this? They know it's festive period, right?
Yes.
So around this time, a person can then make a decision to say, okay, so it seems people have a lot of liquor around November, December. We can increase the price this time. Okay?
Yeah. Yes.
And since people are happy, they will buy anyway. All they want is to get high. So they will buy. Right?
Yes.
Good. So that's now a company making a decision based on data, right?
Yes.
Another example which you are close to, if you want to buy clothes for winter, do you suggest you buy them in winter or in summer?
In summer.
in summer. What is your reason?
Because the sales, the prices will increase in winter.
In winter. Good. So you saw a pattern, right?
Yes.
And you now make a decision to buy winter clothes in summer and summer clothes in winter, right? Because of prices.
Yeah.
So we use the statistics daily. Okay.
Okay.
Now, for our lesson now that we know what happens, then we now want to look into the analysis part. When you are given data, you guys are math people. You are the ones who sit down and do the statistics, okay?
Yes.
So we have what we call measures of central tendency. That is your mean, your mode,
Median,
and your median, right?
Yes.
And when it comes to the mean, that's your average, right?
Yes.
And your average has a notation, x bar, right?
Yes.
The formula is sum of xi from I equals to 1 up to n O over n. What it means is we just add all the data points, we add them and divide by how many they are, okay?
Yes.
If you have points 2, 3, 4, and 1, if I ask you for mean, right?
Yes.
It means you add 2 plus 3 plus 4 plus 1 and divide by what?
4.
By 4, because we have 4 data sets, right? Data
Yes.
points. So if you divide here, what do you get?
2 plus 3 is 5. 2,5. Yes. 2,5.
2,5. That's the average. Are we good?
Yes.
Then we have the mode. When you hear mode, we are speaking of a number with highest frequency or a number that occurs the most, right?
Yes.
If I give you data like this, what is the mode?
2.
2, because 2 appears the most. Are we good?
Yes.
Then we have the median. When we speak about the median, the number one thing to do is arrange data in ascending order.
Yes.
Right?
Yes.
When we say ascending order, do you know the meaning of that?
Yes.
From smallest to largest. Agreed?
Yes.
Okay, good. Then, when you now deal with this, there are things that we need to know. If n is odd, and there's something that happens if n is even, okay?
Yes.
Where n is representing number of data points.
Okay.
Okay?
Yes.
If it is odd, you will need to count the number of steps from left and right, because this is the middle value. So you count some steps to locate this value, okay?
Yes.
So the number of steps, for you to know how many steps to count from the left and from the right, you will say n plus 1 divided by 2, okay?
Yes.
But if the data points are even, you know, even numbers are numbers that are divisible by 2 without leaving a remainder, right?
Yes.
Okay. Number of steps in this case will be n over 2 plus 1. Are we good?
Yes.
Can I give you a mini example?
Yes.
Okay. Find median. And the data is 2, 5, 3, 4, 6, right?
Yes.
Is this data in ascending order?
No. No.
Let us put it in ascending order. What is the first one?
2, 3, 4, 5.
then 6, right?
Yes.
Now, from this, what is the value of n?
It's 5.
It's 5. Is 5 odd or even?
Odd.
Odd,
Odd.
right? So,
Yes.
to know the number of steps, we now do 5 plus 1 divided by 2. What do you get?
3.
It's 3, right?
Yes.
So 3 is not our answer. Okay?
Yes.
It is the number of steps that we are counting from the left and from the right. So we count 3 steps from the left. 1, 2, 3. We mark the value. Okay? Then 1, 2, 3. We mark the value. So the median is what? 4. Are you there?
4. Yes.
You understand, right?
Yes.
Then let's go to see what happens when the data points are even. Okay?
Yes.
In the end, the median will be equals to the mean of the two middle values. You see with the example. Okay?
Yes.
Can I give that example now?
Yes.
Find median. And in this, your data is like this. 2, 3, 4, 2, 3, 5, 4. Is this data in ascending order?
No.
Let us put it in ascending order, right? What is the order?
2, 3, 4, 5.
Now we are good, okay?
Yes.
Then what is n here?
4.
4. Is 4 odd or even?
Even.
Even. So to get the number of steps that we count, number of steps, we will say 4 over 2 plus 1, right?
Yes.
What do you get? 4 over 2 plus 1.
3.
3. So it means we are going to count 3 steps from the left and 3 steps from the right. Are you there?
Yes.
So it's 1, 2, 3. I circle the number. You get it?
Yes.
Then from the right, I count 3 steps. 1, 2, 3. I circle the number. You see that?
Yes.
So in this case, we have 2 numbers in the middle. So the median will be equals to 3 plus 4 divided by 2. That's the sentence where I said it will be the mean of the 2 values in the middle. Okay?
Oh, okay. Yeah.
So what is the answer?
3,5.
3,5. That's your median. Are we good?
Yes.
So this one, it's measures of central tendency. You understand me?
Yes.
Can I move on now to the measures of dispersion?
Yes. Yes.
So what we are doing so far, I am trying to bring this lesson from lower grade, grade 11 and grade 12 at once. I avoid assuming that you remember things, okay?
Yes.
And are you understanding me so far?
Yes.
Okay. So there we go. On measures of dispersion, we have range, right? We have range. We have quartile 1, quartile 2, sorry, quartile 3, okay?
Yes.
Interquartile range. Have you seen these things before?
Yes.
Okay. And I'm not assuming that we are skipping them. Please allow me to go through them as well, okay?
Okay.
Then we have variance, okay?
Yes.
This one also goes with standard deviation, okay?
Yes.
So when you speak of range, now for you to deal with this is important. data must be in ascending order already. Data must be in ascending order for you to discuss these measures. Okay?
Yes.
So when we speak of range, we are saying it is maximum minus minimum. Okay?
Yes.
Then we have lower quartile, the lower quartile. Okay?
Yes. Okay.
For the lower quartile, I think, let me just take this thing. It will help us to be faster. Let me copy it actually. I paste it here. Then we leave this guy where it is supposed to be. Yeah. Now, so we are borrowing something from here. Lower quartile, you need to understand that a lower quartile is the median of the lower half of an ordered data set, right? And it has a formula which says 1 over 4. This color is not powerful enough. N plus 1th position, okay?
Yes.
Or term. Let's put term, okay?
Yes.
So it is the median of the lower half of an ordered data set, Q1, which is written here. Then we have Q2, which is the median, the middle value of the ordered data set. So Q2 can be calculated by 1 over 2 n plus 1th term, okay?
Okay.
Then Q3 is the median. We now know how to calculate median. So when we do examples, I'll put into application these definitions we are seeing, okay?
Yes.
It's the median of the upper half of an ordered data set. So Q3 is 3 over 4 n plus 1 term, okay?
Yes.
So that's your Q1, your Q2, your Q3. Now, when you have Q1, Q2, and Q3, you can calculate the interquartile range, which is given by Q3 minus Q1. Are we good?
Yes.
Then again, on variance and standard deviation, there are formulas we are going to use, but here, in fact, the formulae that is to be used, we don't use them because much of the job is done in a calculator, okay?
Yes.
So the only thing I'll give you here is that variance is equals to, I want to give you the relationship between standard deviation and variance. Standard deviation is equals to the square root of variance. So it means once you get variance, you can get standard deviation.
Yes.
Are we there?
Okay.
Variance is, wait, let me check something here. We have variance. We are looking at the relationship between variance and standard deviation. So we said standard deviation is equals to the square root of variance. So if you manage to get variance, it means you can get standard deviation, okay?
Yes.
And if you get standard deviation, you can get variance by saying variance is equals to standard deviation squared.
Squared.
Okay.
Yes.
Because you have to square both sides from this equation, right?
Yes.
Now, another one that we need to know, it's called a 5-number summary. Okay?
Yes.
A 5-number summary is, it now includes the minimum. So minimum, lower quartile, median, upper quartile, and maximum, right?
Yes.
You already saw the definitions here, but this 5-number summary can be represented in a diagram. That diagram is called a box and whisker. Okay?
Yes.
So a box and whisker takes the minimum, it takes your Q1, it takes your Q2, it takes your Q3, and it takes your maximum. Okay?
Maximum. Yes.
In this lesson, we are just building the theory, all right?
Okay.
And we already know that range, it is maximum minus minimum. Interquartile range, it is Q3 minus Q1.
That's true.
Right?
Yes.
When you see a box and whisker plot, there are questions that will come and ask you to interpret something called skewness. When we speak of skewness, we want to see if data is more to the left or more to the right. Are we good?
Yes.
Can I show you a diagram to interpret that?
Yes.
Okay. So, when we speak of skewness, data can be skewed to the right, meaning positively skewed, or it can be symmetric, meaning not skewed at all, or skewed to the left, meaning negatively skewed. Okay?
Yes.
So if the data is skewed positively and you are looking at that on a histogram, right?
Yes.
They can give you a histogram and ask for skewness. So what you are looking for is where there is a long tail. You see that the tail is longer on the right.
Yes.
So it means the data is skewed to the right. Then if it is symmetrical, the tails are evenly distributed. It's a normal distribution. Are you following?
Yes.
So it is symmetrical. Then if the tail is to the left, then the data is skewed to the left. Are we good?
Yes.
That is you picking skewness from a histogram. But if you are to pick it from the box and whisker, you see that on the right, there is more space.
Yes.
More space between your Q2 and Q3, right?
Yes.
If there is more space to the right, it means it is skewed to the right. Are we good?
Yes.
And then here, the space on the left and on the right is the same. So you conclude that it is symmetrical. Okay?
Yes.
Then if data is skewed to the left, you will have more space on the left between Q1 and Q2. All right?
Yes.
Another way that you can use to interpret skewness is if you compare the mean. Remember, you now know how to calculate mean. You also know how to calculate median, right?
Yes.
Good. So if your value for mean is bigger than the value for median, it is again positively skewed, meaning skewed to the right. Okay?
Yes.
If your mean turns out to be equals to the median, it means the data is symmetrical. Okay?
Okay. Yeah. Yes.
Then if your mean is smaller than the median, it means your data is skewed to the left. All right?
Yes.